All right, trig and pre-calc. So we're looking at arithmetic sequences and partial sums in section 9.2. 9.3, we're going to be comparing these to geometric sequences and series. So just so we have an idea of what kind of knowledge we'll be getting later on, there will be more sequences that have different patterns. So we'll be noticing the patterns with arithmetic sequences, and then we'll get into geometric sequences in 9.3. So for 9.2, for arithmetic sequences and partial sums, a sequence whose consecutive terms have a blank is called an arithmetic sequence. So a sequence is arithmetic if its consecutive terms have a common difference, is what we're going to look for. So in this blank here, we'll put common difference. And so what that means is kind of like what we look at here. We have A1, A2, A3, A4, and that's just the consecutive terms of the sequence. But we know that it's arithmetic if it has a common difference, which is what this is saying right here. So D is going to be our common difference. And D is going to be represented by A2 minus A1, if that's equal to A3 minus A2, and if that's equal to A4 minus A3, and so on. If we go down that line, and if that difference is the same between consecutive terms, then we know it's going to be an arithmetic sequence with a common difference of whatever that number is. So we'll go through example A here real quick. The sequence whose nth term is 4n plus 3 is arithmetic. So let's start with the first term, because we're just given the general statement here. So let's choose a term and then figure out what it is from there. And we're going to find, for each of these, we're going to find D, and we're going to find the first term. And so when I have y'all do the next two examples on your own, find the common difference and find the first term. And you should be able to do both of those, pretty similar to what we're doing here. So the sequence whose nth term is 4n plus 3 is arithmetic. So we're going to choose the first term. So A1 equals 4 by 1 plus 3. That ends up being 7. A2 equals 4 by 2 plus 3, and that equals 11. A3 equals 4 by 3 plus 3, and that equals 15. And if we kept going, we would see that the difference here is 4, difference here is 4, and if we kept going, or if we went to the 0th term, we would see that it ends up being 3, which is a difference of 4. If we went to the 4th term, we would end up with 19, which is another difference of 4. So we can say that the common difference is 4, and our starting value when A equals 1, or our first term when n equals 1 is 7. Because that's what we got when we plugged in 1 for n. So for the next two examples, B and C, in your note packet, feel free to find the common difference and the first term of each sequence. And you might notice a pattern when finding the common difference, and we'll see if you can notice anything else from that. And we'll catch up in a couple sections.